Okay, so just a couple of comments. Looking ahead to next week, Pearson has sent an email out to the instructors. I don't know if they sent it to the students yet, but it should be posted on their website that they are down for maintenance. That's the 2nd and the 3rd. So that's next Thursday and Friday. They will be down. You will not be able to get into it no matter what you try and do. So plan ahead. That does mean that make sure you get Wednesday stuff done on Wednesday. And if you can work ahead, then try to work a little bit ahead, but they will be down for maintenance completely. Due this week on Wednesday is 5-1, Part 1 and Part 2. We will need our graphing calculators for the first time tomorrow. So if you don't have one, you need to get one somehow by tomorrow. I know there's an app on your phone that you can use as a graphing calculator, which will work during lecture and on the homework, but you won't be able to do that on the exam. So again, if you don't have one, I recommend a pawn shop. They're open again, and you can pick one up for about $20 to $30 versus $100. So, and again, I use a TI. Well, that one's not working. 84 plus is what I have, and it seems to work really well. It's got color on it. You don't have to have the color, but it's nice. So, just as a comment for tomorrow. So what we're doing today is we're going to do more of the same thing as yesterday, and then we'll also do some go backward problems. We're going to start off, though, by doing the exact same thing we were doing at the end of class yesterday, and that is graphing polynomials without a calculator. So the directions in the textbook and on the homework are going to have you do this. These are long directions. They've got multiple parts for it. So for each polynomial, we're going to do all the kinds of these bunch of steps. So we want to find the intercepts. We want to determine whether the graph crosses or touches at each x-intercept. That relies on that multiplicity. We want to do the end behavior. Which is the power function. We want to determine the maximum number of turning points. And we did all of these steps yesterday, so they're not new. E is the one that's new. We want to determine the behavior of the graph near each intercept, near the x-intercepts. And that's the only thing that we're really adding in today right now is that. And then part F is to graph the function. So it's a lot of parts to it. Okay, so those are all the steps. That's a lot of steps when you look at them. So again, these problems have multiple parts. You don't have a lot of them, but they all have these multiple parts to them. What they're really doing is just walking us through the process in little steps more than anything else. So we're going to start off fairly gentle. I'm going to leave those there for just a second. So I want to graph the polynomial function f of x is equal to x squared times x minus 3. So x squared times x minus 3. So a nice little polynomial function. Not a lot of anything to it. It's fairly short. Okay, so what we want to do is walk through these steps, and then we'll erase the steps. So part A is to find those intercepts. So let's go find the x-intercepts. Okay, that comes from setting every single factor equal to 0. If we set x squared equals 0, we're going to get a 0. And because I'm calling it an x-intercept, it's also known as a 0. But because I'm labeling it as an intercept, I'm going to write it as a point. I'm going to go ahead and address part B at the same time because it's just easiest on the board. So its multiplicity is 2. And do you remember what that tells us from yesterday? So when it has an even multiplicity, is the graph touching or is the graph crossing?
Touching, right?
Yes, correct. So it's going to touch. And think about the x squared, the parabola, how it bounces. So that's the easiest way to remember it. Our other x-intercept is going to be at 3, 0. Its multiplicity is 1 because it has an outside exponent of 1. So what is that one going to do? Cross or touch?
cross.
Beautiful, because it's an odd multiplicity. And again, it's the multiplicity even and odd, not the number even or odd. We also need a y-intercept. A lot of these, this is what I call the no-brainer question. And the reason is because if we already know we're crossing the x-axis at the origin, you have to cross the y-axis there also. But again, you can find that by finding f of 0. When we plug 0 in, we get 0 squared, which is 0 times anything is 0. So the y-intercept is 0. Okay. So we did A and B. We kind of did them at the same time. Again, on the Pearson homework, you're not going to be able to do that. They'll walk you through it with a bunch of words. Okay, part C is the end behavior. That was part B sitting there. Okay, the end behavior. Yeah, what the graph is doing at the ends, and that comes from the power function. So what we need to do is figure out if we were to multiply everything out, what would we get? Well, we'd get an x to the third power. So the power function is x to the third. So that means it's a degree 3, and that tells me about my end behavior. So because it's a third degree with a positive leading coefficient, we know it's going to start below and end above. So it will look something like that when we're all done. We got stuff going on in the middle, but at the ends, this is what's happening. Again, that was the odd degree and a positive leading coefficient. So it mimics an x cubed. Okay, so part D is the maximum number of turning points. So TP for turning points, that's the degree, which was 3, minus 1, which is 2. So at most, it's going to change directions twice. Okay, that brings me to part E, which is the only part we didn't talk about yesterday. If, again, I were collecting homework, we would omit part E. I don't think it adds to the picture at all. But because you're doing the online homework and I can't omit the parts, we have to address it. So for part E, what I'm going to do is make a little table. And the table is going to be my x-intercepts, and then I'm going to explore what's going on around them. So we know that the first x-intercept is at the origin. So at 0, 0, I need to explore on either side of 0. So what we're going to do, actually, let's not, you can tell I haven't lectured on this because I don't think it's necessary. I'm not going to call it x-intercepts. I'm just going to call it x and then y. So we need to explore on either side of 0. So I'm going to plug in a -1, and then I'm going to plug in a +1 into the function. So I need to know what it's doing on either side of 0. So I'm just going to plug numbers on either side of 0 into the function. So if we plug in a -1, we'll have a -1 squared times -1 minus 3. Well, -1 squared is a +1. -1 minus 3 is a -4. So we end up with -4. Okay, what is that telling me? Well, hang on. Let's plug in the +1 and do the same thing. So you get 1 times a -2, which is a -2. Okay, so what now we just established is when we hit the origin right here, we know that on the left side at -1, it's negative, right? It's down there at -4. And on the right side at +1, it's still negative. So it's down here. So what we've just established, which we already knew, is that the graph is bouncing or touching there. That's what we said. We said the graph is going to come in and touch. So what this is really doing is telling you that it's coming in from the bottom and heading out on the bottom. So it's below the x-axis and below the x-axis. So in terms of the behavior of the graph near each intercept, we know that it starts below and it ends below. So that's all that did for us. We already knew it. Okay, and then we're going to go investigate the other one, which was 3, 0. So I'm going to do the same thing again. I need to pick numbers on either side of 3. So we'll pick a +2 and a +4. So on either side of 3. So now we're looking down here at 3 and figuring out what's going on. So we plug in the 2, we get 2 squared times 2 minus 3. So that's 4 times a -1, which is a -4. So that tells us it's coming in from the bottom. Then we have 4 squared and 4 minus 3. So that's 16 times 1, which is 16, which is positive. So this is simply telling me that at 3, the graph is coming in from the bottom, and it's going to finish at the top. So it's clear up there at 16. So it's coming in and starting here and doing here. So we already know that it's going to cross there. We've just verified that. You can also do decimal numbers in here. I tend to use whole numbers, but if I'm going around 0, I could have used a negative 0.5 and a positive 0.5. If I'm coming around 3, I could use like 2.5 and 3.5. I'm just trying to make it easier in terms of what we're doing. Okay, I'm actually going to erase that because everything we need is basically sitting over here. So now we can go graph it. Again, take advantage of the nice straightforward homework that you have. Okay, so we have an intercept at 0. We have another one out there at positive 3. We basically just had a bunch of points. If you wanted to plot points, you could. But we already know the graph is going to start below because of this information. So it's going to start to the left and below. At the 0, we saw that it's going to touch, so it comes right back down. We know it has to get drawn back to the next x-intercept. And at that next x-intercept, it's going to cross. And there's our picture. We don't know how far down it is, but remember just a few minutes ago, we had some points at 4 and 4. So it probably peaks right below it somewhere. And there it is. There's your graph. You've done all the part to it. And now we're just going to get practice doing a couple more of those before we move on. So, any comments or questions? Again, it is some of the friendliest graphing we do. Okay, we're looking good. Okay, let's try another one. A little more complicated. How about, it's where I never have enough room. Let's do f of x, which is equal to, we're going to do x plus 2 quantity squared and x minus 2 quantity squared. So x plus 2 quantity squared times x minus 2 quantity squared. So it's a polynomial function. It has no funky exponents. Everything's got positive. It is in factored form. What we're going to have is an issue moving forward the rest of the week is they're not going to be in factored form. This one's in factored form for us. Okay, so let's come in and go walk through our steps. So let's go find the intercepts. So you tell me, where are my x-intercepts? So what's one of the x-intercepts? If you set one of the factors to 0, you're going to get what? Yep.
-2.
Good job. And what's its multiplicity, Rich?
1.
What's its outside exponent? A 2. And that means the graph is going to touch. So it all ties together. That's why I do it all at the same time. Okay, somebody else give me the other x-intercepts. I've heard from Rich.
2.
Beautiful. What's its multiplicity?
2.
Yep, that's that outside exponent again. And that tells me the graph is again going to touch. Nice. So that's part B right there. We also need our y-intercept. So we're going to plug in f of 0, plug 0 in for all the x's. So that would be 0 plus 2 squared, which is just 2, and 0 minus 2 squared. So I drop all the x's out of there and just write the numbers with their signs. So 2 squared is 4, negative 2 squared is also a positive 4, so we're going to end up with 16. So that's 0, 16 is our y-intercept. Again, the y-intercepts themselves will be kind of ridiculous in terms of trying to get it plotted. So you guys have a grid on the MyLabs. So, okay, part C was to find the end behavior. So the first thing we're going to do is talk about the power function. So if you were to multiply everything out, which again, you're not going to do, but if you were to multiply it all out, you would end up with an x to the what power? Yep, beautiful, 4. So you can look at that a couple of ways. I'm simply adding these two together, or you can come in and look at your multiplicities and add them together. But it's x to the 4, so that means it's a 4th degree polynomial. So the degree is 4, and now we can talk about the end behavior. So I go back to my little chart from yesterday. It's an even power function, and the leading coefficient is positive because there's a positive 1 sitting out in front of it. So that tells me that it's going to start above and it's going to end above. So when I'm all done, my graph will look like this on the ends, and that's the end behavior. I think that's the only sneaky point in there. Part D is asking for the maximum number of turning points. So again, the turning points is the degree of 4 minus 1, which is 3. So at most, it will change direction 3 times. It does not guarantee it, but at most, it will change direction 3 times. Okay, I'm actually going to go ahead and skip part E, only because, again, it just is plugging numbers in, and you can do that. You don't need that for me at all. So let's go graph it, figure out what we've got going on. So we have -2 and a +2. There's my 2 y-intercepts. I'm sorry, there's my 2 x-intercepts. My y-intercept is way up there at 16. So again, what I can do literally on the board is just make a point and mark it at 16. You will have a grid on the homework to be able to plot it. So, okay, now we're going to follow what we know. So we know we're going to touch at each of those intercepts, but we have to start above the axis this time. So I'm going to come in from the left side and head towards that first x-intercept. And at that point, we know that the graph is going to touch, which tells me it comes right back up. So I'm going to head up towards my y-intercept and then get pulled back down to the next x-intercept. And at the next x-intercept, again, that's the +2, said it was going to touch or bounce. So we will head right back up. So it's going to look like a W. And I'm willing to bet, because of the symmetry going on, that 16 is probably the peak of this thing. But again, we don't know that for sure. And again, if you were going to test on either side of the x-intercepts, you could plug in something like a -2.1 and a -1.9, or a +1.9 and a +2.1, and you'll see that you're positive on both sides. And there's your graph. Comments or questions? They're kind of fun. Go ahead and say it. Math is fun. Okay, let's do one more. This one's going to have a slight twist to it. So this time, let's graph f of x is equal to a -x² times x minus 2 times x² plus 3. Okay, so a -x² times x minus 2 times the quantity x² plus 3. So again, it's in factored form, which is wonderful for us. Let's come in and find our x-intercepts and our y-intercepts. So the intercepts are always first. Okay, what's my first x-intercept? So from this x² that's sitting out in front, we know we have an x-intercept of what?
2. 0.
Okay, so we've got a 2, 0. That's this 2, right?
Mm-hmm.
Its multiplicity is 1, so the graph is going to cross. And again, that's this guy. Okay, but if I set that -x² that's out in front equal to 0, I can divide out the negative and then square root, and won't we get an x equal to 0? So anytime you have an x out in front, you also have the origin as an intercept. What's its multiplicity?
2.
So we know the graph is going to touch. Okay, now we're looking at the ugly factor. Notice that this guy's not factored. The exponent's on the inside, not the outside. So if I take x² plus 3 and set it equal to 0 and try and solve that, then x² would be equal to a -3. If I square root, I'm going to get x equals plus or minus I times the square root of 3. So this x² plus 3 does not contribute to the x-intercepts. So there's no x-intercept from that x² plus 3 because it's a plus. So it has no x-intercepts. So that's it. I only have 2. I have the +2 and the one at the origin. Okay, what about a y-intercept? Well, we already know that we're crossing the x-axis at the origin. So when I plug in 0, won't we get 0? So the y-intercept is 0, 0. So again, let the problem work for you. If you know you already have the origin, then you already know what the picture is doing there. Okay, the next step was the end behavior and the power function. So this is step C. So I'm going to go look at the power function first. Okay, this one's the sneaky one. That x squared plus 3 is contributing to the overall degree. So when I come in to look at the power function, I have to add the x squared. So there's a 2. There's the 1 off the x minus 2. So now I'm up at 3. And the x squared, there's another 2. So altogether I have 5. So this is a negative x to the 5th. The negative is coming from the negative that's out in front off the leading coefficient. So is everybody clear on the 5? That's the 2 off the x squared, a 1 off the first factor, and a 2 off that second factor. So the overall degree of our polynomial is 5. So then my end behavior this time, it is an odd degree, but it has a negative leading coefficient. Normally odd degrees would start below and end above, but the negative is going to reflect it across the x-axis. So this one's actually going to start above and end below. So again, that's the negative doing the reflection that we know from our transformation work. Okay. Part D is the turning points. So at most, it's going to turn 5 minus 1, which is 4 times. So at most, it'll turn or change direction 4 times. Part E is to investigate what's going on. We kind of already know what's going on because we talked about the touching and the crossing. Okay, we're ready to graph it. Okay, what do we got? We got the origin and a positive 2. So when you first look at these, it's like, all I got is 2 points. Not a lot to graph from. But again, we're going to let the work that we've done work for us. So we know that this time we're going to start above. So on the left side, we're coming in from above. We're going to hit that x-intercept, and we said at that x-intercept, which is the origin, the graph is going to touch. So we're going to head right back up. Then we're going to get pulled to the next x-intercept. And at that x-intercept, we know the graph has to cross. There's no further x-intercepts to pull it back to that x-axis, so it's not going to make another turn, and that's it. So this one only has 2 turning points, definitely not 4 of them. That's the multiplicities coming into play. But there it is, and notice we ended where we said we should end, below. So, okay, are they getting easier?
Yes.
Yay. Okay, let's go do one that's not in factored form. So I want to do the same exact set of directions, but this time my polynomial is going to be f of x is equal to 4x minus x cubed. So 4x minus x cubed. That's in standard form. So again, I'm going to make myself a note that it is not in factored form. It's in standard form. But it's not even in descending order. So the first thing I'm going to do is make it in descending order, negative x cubed plus 4x. That just makes it friendlier. Now there are parts that we can tell from this point of view. So I don't normally like to do things out of order, but I'm going to go look at part C, which talks about the power function and the end behavior. And the reason I'm going to do that is because I can see the power function right off the bat. So I know my power function is negative x cubed. Because it's in standard form, I don't have to mess around with it. I just look for the largest exponent. That's my leading term, and I know the power function. So this is another 3rd degree polynomial. And as far as the end behavior goes, because it's got a negative on it, it's going to reflect. Normally it would start below and end above, but we'll reflect it. So it's going to start above and end below. Okay, now we're going to backtrack. In order to get the rest of the information, we have to factor it. So our next step is going to be to factor it. So we need to factor. So to pull off the x-intercepts and the y-intercepts and everything, it's just easier to go to that factored form. These will be factorable. So again, I'm going to work off this negative x cubed plus 4x. Can't we pull out a negative x? So the first thing we're going to do is factor out a negative x. That'll make that a positive x squared minus 4. And then can I factor it further? Well, yeah, x squared minus 4 factors further. That factors into x plus 2 and x minus 2, and now it's in factored form. Now we can pull off all our information that we need. Again, the x squared plus 3 in the previous example did not factor because it's a plus, but because we have a minus, this factors. Okay, let's go pull off our x-intercepts then. I'm going to give you a minute. You write down the 3 x-intercepts and tell whether it crosses, what their multiplicity is and whether we're crossing or touching. So I'll give you a minute to do that. So from the negative x that's out in front, when I set that to 0, I'll get the origin. Its multiplicity is 1. From the x plus 2, when you set that to 0, you'll get a negative 2. Its multiplicity is also 1. From the x minus 2, you'll get a positive 2. And its multiplicity is 1. And because all of these are odd, we know the graph is going to cross at all of them. So we're going to cross. Okay. What about the y-intercept? When you plug in 0, you should get a 0. That's actually fairly easy to see in the standard form back up here because there's no constant added on to the end. This would be 0, this is 0. Or again, because we know we already crossed at the origin, we have to cross again at the origin. We already talked about the end behavior, so we're good to go on that. Part D was the turning points. That's the degree, which was 3 minus 1. So at most, we're going to change direction 2 times. Okay, now we're ready to graph it. So we have a negative 2, no origin, and a positive. This one's a really pretty one. So we know it's going to start above and end below, and we're going to cross at everything. So we simply are going to come in and draw a nice smooth polynomial. It starts above, crosses at all of them, and ends below. And I have a feeling that these peaks and troughs are probably symmetrical in terms of things. If we talk about symmetry, notice this has symmetry to the origin. If we fold this over and then flip it, it will fold on top of itself. So it's an odd function, which kind of fits from what we know before. And there it is. Again, enjoy it while it lasts. So any comments or questions about that one? Okay, now we're going to go backwards. I'm sorry, question? Or we're good?
Nope, we're good.
Yeah. See, this is the problem because I can't physically see you. I don't know whether you're talking or not unless I look at your little microphone. Okay. So now we're going to go backwards. So in other words, if I give you the graph, can you write the function? Okay. So we want to find polynomial function that might have the given graph. Okay, so find a polynomial that might have the given graph, and the picture is going to look like this. So we're going to go through the origin. We're also going to go through the point at 2, and it looks like that. Sorry, that is right there. Yay. So what we're going to do is exactly the opposite of what we just did. We have to pull all the information together because this is starting below and ending above. We know that when we're all done, we should have an odd degree. So this is an odd power function, and that's because they're ending and, sorry, it's starting and ending on opposite sides, so it's got to be an odd power function. What we're going to do is use those x-intercepts to rebuild it. So I'm going to put that dummy a out in front again. You'll see why we need that here after a couple of examples. But there's my a, and now we're just going to use those x-intercepts. So I have an x-intercept at the origin. So I know that comes from an x minus 0. We'll clean it up in the next step, but that's an x minus 0. Now, what about its multiplicity? Well, because the graph is crossing there, I know it has to have an odd multiplicity, and the easiest odd multiplicity is a 1, so I'm going to give it a 1. I could give it a 3, I could give it a 5, but the easiest one to deal with is a 1, so I'll go for the easy guy. Okay, the next x-intercept is at 2, so that's going to come from x minus 2, and because the graph is bouncing or touching there, we know it has to have an even multiplicity. So we're going to give it a 2 because, again, it's just the first even number. So right now, this is what we've got. F of x is equal to a. I'm going to get rid of that first set of parentheses. Ax, and then we'll have an x minus 2 squared. Okay, so in order to find a, I physically need another point. And so on this particular graph, we have a point up here at 1, 2. So find a. We're going to use another point on the curve. So we're going to come in and we're going to let y be the 2. And we're going to replace all the x's with a 1. Because x is 1, y is 2. So I let f of x, which is my y, be the 2. And I'm going to replace all those x's with a 1. And then I just have to clean that up. So that's a 1. That's a negative 1 squared. So negative 1 squared is a positive 1. So it looks like I'm going to get a is equal to 2. So I now know the coefficient out in front is doing a little bit of stretching. It is a positive 2 like I expect it to be because of where it's starting and stopping. So when it's all said and done, f of x is equal to 2 times x. I don't know why I keep wanting to put parentheses there. I don't need them. 2x times x minus 2 quantity squared. Now, as far as I'm concerned, you're done. The book may make you, the online homework may make you FOIL this out, so be very careful with it. This is all I'm after, so you can call it quits as far as I'm concerned there. So it's not too hard to go backwards. You just have to keep track of that A. Okay, we're going to do one more just to make sure you've got it. This one will have a different y-intercept, so. So same directions, just going to switch the graph. So this time, we've got an x-intercept over here at -1. We've got one at +1, and we've got one at 2. And my y-intercept is going to be up here at 4. So the graph comes in, bounces, and does something like that. So it looks something like that. So again, -1, +1, 2, and we're on the y-axis at 4. Okay, so because it's starting and stopping on the same side, I know it needs to be an even degree when it's all said and done. And because it's starting and stopping below the axis, I know it's going to have a negative leading coefficient. So in other words, we should end up with A being less than 0 because it's been reflected. Normally a parabola opens above, this one's opening below. So, okay, so when I'm all done, I'll double check to make sure we're on the right track with that. So f of x is equal to, we'll put our A again in front. Okay, this x-intercept is over here at -1. So as a factor, that's going to come from an x +1. Again, notice that I switch its sign when I pull it into the parentheses or take it out of the parentheses. That's still not an x. Okay, and because this thing is crossing, I'm going to make that a first degree because it's crossing. Our next x-intercept is over here at +1. So that's going to come from an x -1, but the graph is bouncing or touching there, so we'll make that an even exponent of 2 because it's the easiest one to deal with. We have one more x-intercept over there at 2. That comes from x -2 as a factor, and because it's crossing, we'll leave it as an odd exponent of 1 on the outside. Okay, now all we have to do is figure out what A is. So this time we're going to use the y-intercept. Use the y-intercept of 0, 4 to find A. Much easier than the last one, so that would be 4 is equal to A. All the x's are now 0, so I'm going to have 1 times a negative 1 squared times a negative 2. So a negative 1 squared is a positive 1. 1 times negative 2 is a negative 2, so I end up with a negative 2A. So it looks like A is going to be a negative 2. You can get a fraction, so don't, both of my examples are whole numbers, but it's okay if you end up with a fraction, so be careful. Okay, so that means my polynomial is f of x is equal to a negative 2 times x plus 1 times x minus 1 squared times x minus 2. And there's one polynomial function that might have that graph. And again, other possibilities exist. I mean, you could come in and change those exponents to other odds and evens. So in other words, you could give this guy a 3, you could make this a 4, and you could make that a 5. It would still have the same basic characteristics, but that A is going to get really adjusted to force the y-intercept where it needs to be. So, okay, and that wraps up section 5.1 for us. It should be a fairly friendly homework. Make sure you follow all the directions on the homework. So, any comments or questions?
Nope, I'm good.
Look, we're done early for once. Okay, so again, graphing calculator needed tomorrow. I will send out lecture notes here in a bit, so we'll have some new lecture notes for tomorrow too. And we skip up to 5.5 tomorrow, so don't freak out on me when I skip a bunch of sections. We'll come back and do it. So have a great day. Enjoy the weather. Try to do something fun, not work.
Thank you too.
Bye-bye.